Digitizing Your Neighborhood. Hello, my name is Nick Malloy, and in this video, we'll be digitizing your neighborhood. This video is a demonstration that follows the written instructions published on the Geospatial Institute website. Keep in mind that the written instructions can change over time as software and workflows change. If you're enrolled in this course, you should also check Canvas for details about what you need to submit at the end of the lab, since those requirements can vary by instructor. Okay, let's get started. Setting up your workspace. Before we start working in ArcGIS Pro, we need to take a moment to set up your workspace. File management is a core GIS skill, and it plays a much bigger role in this lab than it might seem at first. Most GIS projects rely on data stored on a local hard drive while you're actively working, with backups stored elsewhere. For this lab, we'll use the computer desktop as our local working location. What you want to avoid is jumping ahead without a clear folder structure. Small mistakes here tend to cause a lot of confusion later, so let's slow down and set this up carefully. On your desktop, create a new project folder and name it Digitizing Neighborhood. Make sure there are no spaces in the folder name. Using spaces can lead to problems later on, so use an underscore instead. Inside that folder, create 3 subfolders named Original, Working, and Final. The original folder is where you will store any source data that should stay unchanged. The working folder is where you will save the data you create and edit during this lab. The final folder is reserved for finished outputs, such as maps or other deliverables. This structure keeps your project organized, and it makes it much easier to track your work as the lab progresses. Downloading the project data. To get started, we need to download the imagery for this project. Use the link in the instructions to download the NAIP file. When the Google Drive opens, you may see a message saying that it can't preview or scan the file. That's expected. You don't need to open or preview it. Just go ahead and download the file anyway. Once the download is complete, open your downloads folder and locate the file name arcada-naip.7z. From here, cut that file and paste it into the original folder inside your project directory. It's important that the file is in the correct location before you extract it, since that determines where all the data files will end up. To extract the file, I'm going to use a shortcut that I like, which is a right-click drag on the file. When you release the mouse button, that brings up the 7-zip options, and I'll choose Extract Here. Once the extraction finishes, you can delete the original 7z file. Inside the extracted folder, you'll see 2 NAIP images, one for the north and one for the south. Each image is made up of several related files. That's normal for GIS data, so make sure all of those files stay together. Setting up your project in ArcGIS Pro. Now that the project data is set up, we can create a new project in ArcGIS Pro. If this is your first time opening ArcGIS Pro, you may be prompted to sign in. If so, go ahead and sign in before continuing. On the ArcGIS Pro Start screen, choose Map under the New Project options. When the Create New Project window opens, name the project Digitizing Neighborhoods. It's fine to use spaces in the name. The next 2 steps are important, so don't skip them. First, use the folder icon to set the project location to your Digitizing Neighborhood folder on the desktop. Then make sure the option to create a new folder for this project is unchecked. You would only leave that option checked if you still needed ArcGIS Pro to create the project folder for you. In this case, we already created it earlier. When the project is created, ArcGIS Pro automatically adds several files and folders to your workspace. If you open your project folder in Windows File Explorer, you'll see your original, working, and final folders, along with a few additional items, including a geodatabase and the ArcGIS Pro project file. These files are required for the project to function properly, so don't delete or move them. You can also see these default project files inside ArcGIS Pro by opening the catalog pane and expanding the folders. Removing the default Esri basemap. By default, ArcGIS Pro will load an Esri basemap. In many situations, that's fine, but for assignments in this class, you generally should not use Esri basemaps in your final map layout. Since we'll be creating and using our own basemap data, it's a good habit to remove the default basemap right away. In this case, the dark gray basemap is loaded, along with its reference layer for labels. In the Contents pane, remove the basemap layer and also remove the reference layer that goes with it. Skill drill, adding data. For this activity, we'll use the NAIP imagery as our basemap layer. In the original folder, you should see two image files, Arcata North NAIP.tif and Arcata South NAIP.tif. Go ahead and drag both of those files onto the map pane. As the images load, ArcGIS Pro may ask if you want to build pyramids. If that message appears, click Yes. That's normal, and it will help the imagery draw more efficiently as you zoom and pan around the map. Skill drill, checking the spatial reference system. Before we move on, we need to check the spatial reference system used by the NAIP imagery. This is something you always want to verify rather than assume. In the Contents pane, right-click one of the NAIP image layers and open the layer properties. In the Properties window, go to the Source tab. Here you can see the spatial reference information for the imagery. In this case, the NAIP data is using a projected coordinate system. Specifically, it's NAD 1983 UTM Zone 10 North. Make a mental note of that. Later in the lab, you'll be creating new shapefiles, and you'll want to match their spatial reference to the imagery you're using as your basemap. Locate your neighborhood. At this point, go ahead and navigate to a neighborhood that you want to work with. This tutorial assumes you're somewhere in Humboldt County, but that isn't required. If you'd rather not use your own neighborhood, or if you live somewhere else, you can choose any neighborhood you like. If you're not sure where to start, the Cal Poly Humboldt campus is a good option. Creating new shapefiles. We'll start by creating the shapefiles we'll use for digitizing. We'll do this from the Catalog pane. In the Catalog pane, right-click the working folder and choose New, then Shapefile. Name the first shapefile Buildings and set the geometry type to Polygon. For the coordinate system, match the spatial reference of the NAIP imagery, which is NAD 1983 UTM Zone 10 North. Then run the tool. As you can see, the new shapefile was created in the working folder. Next, repeat this process to create a shapefile named Trees. This time, make sure you change the geometry type to Point. And again, match the spatial reference to the imagery before running the tool. Finally, create a shapefile named Streets. For this layer, use a polyline geometry type. And make sure the spatial reference is set correctly before you run the tool. When you're finished, you should have 3 shapefiles in your working folder: buildings, trees, and streets. These layers will be used to digitize features in your neighborhood. Drawing your world. Now we're ready to start digitizing. To do that, open the Create Features pane. This is where you choose the layer you want to draw and activate the drawing tools. We'll start with the Buildings layer. Select it in the Create Features pane to activate the Polygon tool. Before drawing anything, there are 2 quick things I want to show you. First, while you're digitizing, you can hold down the C key to temporarily pan and zoom around the map. This makes it much easier to move around without exiting the drawing tool. Second, I'm going to adjust the symbology for the buildings layer. Changing the outline color and removing the fill can make it much easier to see what you're drawing, especially when polygons overlap imagery. This step is optional, but it can really help with accuracy. Once that's set, go ahead and begin digitizing the building footprints. Click around the edges of each building and double-click to finish the polygon. Take your time and focus on clean shapes rather than perfect detail. For this step, digitize 8 buildings. After that, turn on snapping. Snapping helps ensure that the features connect cleanly and don't leave small gaps. Next, switch to the Streets layer in the Create Features pane. Streets are line features, so you'll be digitizing them one segment at a time. Click once to start a line at an intersection. Then double-click at the next intersection to finish the segment. I want to pause here to show you an example of what not to do. Leaving small gaps or dangles between street segments is not good practice and can cause problems later. If that happens, delete the segment and redraw it, making sure snapping is helping the lines connect cleanly at intersections. Digitize at least 2 street segments in your neighborhood. If your area has more intersections, you're welcome to add more. The important thing is that street segments connect cleanly and don't leave gaps or dangling ends where they should meet. Next, move to an area with several trees and switch to the Trees layer. Trees are point features. As you digitize, place each point where you think the tree trunk would be located. You don't need to be exact. Consistency matters more than precision here. Digitize 20 trees. When you're finished digitizing, save your edits using the Save button on the Edit ribbon. This step is important. Saving edits commits your work to disk. Finally, switch back to the Explore tool on the Map ribbon to deactivate the drawing tools. Enhancing your data with attributes. In GIS, features are not just shapes on a map. They also have attribute information stored in a table. In this step, we'll add new fields and calculate the area of our buildings and the length of our streets. Before we do anything with the attribute tables, make sure to save your edits. This is important. If you have unsaved digitizing edits, the Add Fields button can be grayed out and you won't be able to continue. To save your work, go to the Edit tab and click Save. This is different from saving your project. Saving the project saves your map and settings. Saving the edits writes your changes directly to the shapefile. We'll start by calculating the building area. In the Contents pane, right-click the Buildings layer and open its attribute table. At the top of the table, click Add Field. This opens the Fields view. In the first empty row, set the field name to Area. By default, the data type is set to long, which stands for long integer. Change the data type to double so that the field can store decimal values. From here, there are two ways to save the changes to the attribute table. You can click the Save button on the Manage Edits group, or you can just close the Fields view and ArcPro will prompt you to save. Back in the attribute table, you should now see the new area field. To populate it, right-click the header on the area field and choose Calculate Geometry. For the property, choose Area. For the area unit, select Square Feet United States. For the coordinate system, choose Current Map, then click OK. ArcGIS Pro will calculate the square footage of each building polygon. Next, we'll do the same type of workflow for the streets. Open the attribute table for the streets layer and add a new field named Length. Again, using the double data type. Save the field changes. Then right-click the header of the Length field and choose Calculate Geometry. For property, choose Length. For the length unit, select Feet United States. For the coordinate system, choose Current Map and click OK. ArcGIS Pro will calculate the length of each street segment in your new field. Documenting your data with metadata. Metadata is simply data about data. It tells a story of what this data set contains, how it was created, and who is responsible for it. In professional GIS work, metadata is part of delivering a professional quality data set. Before we start editing metadata, we need to make sure ArcGIS Pro is using the correct metadata settings. Go to the Project tab and click Options and open the Metadata section. ArcGIS Pro includes different metadata styles, and you'll choose one from this drop-down menu. For this lab, set the metadata style to ISO 19139 Metadata Implementation Specification, and make sure you choose the plain option, not the one that includes GML 3.2. ISO 19139 is an international metadata standard. In simple terms, it defines a common structure for metadata so that the information you enter can be shared and understood consistently across different systems and organizations. At this point, you'll notice that ArcGIS Pro gives you two different options for editing metadata. There's the classic metadata editor, and then there's the newer ArcGIS metadata editor. Both editors are working with the same underlying metadata content, but the experience of editing is very different. The first big difference is which metadata styles the editor supports. The classic editor supports all of the metadata styles in ArcGIS Pro, including the default item description style. The newer editor is more focused on standards-based styles, like ISO 19139. It doesn't support the item description, which means you may not even see it as an option unless your style is set to a standards-based format, like the one we just selected. The second difference is how the interface is organized. In the classic editor, you navigate through a table of contents with a series of pages, and you click into those pages to find the fields that you need. In the new editor, you mainly work in two views. The first is essential metadata, which brings the most important required elements together in one place. The second is all metadata, which gives you access to everything organized into sections. And the last major difference is how each editor helps you validate what you've entered. In the classic editor, missing information is flagged on specific pages, and you have to click into those pages to see what needs to be fixed. In the ArcGIS metadata editor, you get a required elements panel on the right that acts like a checklist. As you fill things in, you'll see the items turn into green check marks immediately. One quick note, if your ArcGIS Pro interface looks different than what I'm showing here, it may be because you're using an older version. Some older versions don't include the option to switch editors and will default to the classic editor. Select the ArcGIS metadata editor and then click OK. Editing metadata from the catalog pane. Now we're ready to edit the metadata, and the way you open it matters. To make permanent changes, you need to start from the catalog pane. Browse to your working folder, right-click the building's shapefile, and choose Edit Metadata. This opens the editor for that dataset, and when you save, those changes are written to the file. At the top, click Essential Metadata. When the editor opens, you may not see the Required Elements panel yet. If your catalog pane is taking up the right side of the screen, go ahead and pin it. Once you do that, the Required Elements panel will appear. Now we can start working. We'll begin with title. Working through the required metadata. Title is the first required metadata element. You can think of it as the dataset's main label. It's what shows up in catalogs, search results, and pop-ups, so it should clearly describe what the metadata contains. Click into the title field and enter a short, clear title such as buildings. As soon as you do that, look over at the required elements panel on the right. You should see it update and a green check mark will appear. Description abstract. The description abstract is the narrative explanation of your dataset. In professional GIS work, this is one of the most important parts of metadata because it gives future users the context they need to understand what the data represents and how it should be interpreted. When a dataset is shared, published, or discovered through a catalog, the abstract is often the first place someone looks to understand what they're dealing with. A good abstract should be short, clear, and informative. It should explain what the dataset represents, how it was created at a high level, and what source information you used, and any important limitations. The goal isn't to document every step you took. It's to describe the dataset well enough that another GIS user could decide whether it fits their needs. To enter the abstract, click the Description Abstract in the Required Elements panel on the right. Notice how the editor scrolls directly to the correct field. In the text box, write a single paragraph. I'm going to use the example from the instructions. This example applies to the buildings only. Don't try to use it for the streets and the trees. You'll need to come up with your own description. Resource language. The resource language identifies the language used in the dataset itself, meaning the language of any text content stored in the data. For this lab, think about text that appears in attribute tables like names, labels, or notes. To fill this out, click Language in the Required Elements panel to jump to the Resource Language card. Then use the drop-down menu and select Language. In this example, I'm selecting English. If you're completing this activity in a different language, choose a language that best matches how you would represent the text content in your dataset. Citation Dates. Citation dates record when a dataset was created and later on when it was updated or published. These dates help someone understand how current the data is and give a simple history of the dataset. Even for a small project like this, dates are a basic part of good documentation. For this lab, the only date we need to enter is the created date. To fill this out, click the calendar icon next to Created and select today's date. Metadata language. The metadata language is the language used to write the metadata itself. In some professional settings, the same dataset may have metadata written in multiple languages. So this field makes it clear how this metadata record should be read. I'm going to use the drop-down menu and select English, since that matches the language I'm using to write the metadata. Metadata Scope. Metadata Scope is simply answering the question, what am I describing with this metadata? Are you documenting an entire dataset or something smaller inside it? For this lab, we're documenting each layer as a whole. So when you write a title or description, you're describing the entire buildings layer or the entire streets layer, not one specific building or specific street segment. To set this, use the drop-down menu and select Dataset. After you do that, you may notice that additional elements appear on the side panel. That's expected. With ISO metadata, ArcGIS Pro uses conditional requirements, and choosing the dataset scope triggers a few new items that we need to complete next. Topic category. Topic categories are a standardized way to describe what a dataset is about. Unlike tags or keywords, where you can write anything you want, topic categories come from a fixed list in the ISO standard. The benefit is consistency. If everyone uses the same list, datasets are easier to sort, filter, and find in a catalog. To fill this out, use the category that best fits this layer. For the buildings dataset, select Structure. Geographic Extent. The geographic extent tells someone where this dataset is located. It gives your data a spatial footprint, so it can be mapped, indexed, and discovered in a catalog. To set it, go to the Geographic Extent card and find the bounding box section. You notice that the values start out at 0, which just means that the extent hasn't been defined yet. Click Select Extent to activate the small map preview. Use the map to zoom into the area you digitized and make sure the view includes all of your features. You want enough surrounding context to make the location clear, but not so much that you're including large, unrelated areas. Once the map is showing the right area, click Draw Extent. ArcPro will fill in the coordinates for you automatically. Geographic Description. The geographic description is a place-based way to describe where a dataset is located. Instead of using coordinates, it uses a recognized place name, like a city, region, or other geographic area someone would understand. Since we already used a bounding box, this part is optional for this lab, but it can still be useful because it gives a human-readable location. Enter a clear place name that matches where your digitized features are located. In my case, I'm entering Arcata, California, USA, because that's where my neighborhood data is. If you digitized a different area, enter the city and region that makes sense for your dataset. Metadata Contact. The metadata contact identifies who is responsible for the metadata record. In other words, it answers the question, who wrote this documentation? In professional GIS work, metadata should not be anonymous. This contact information gives future users a clear person to reference if there are questions. Enter your name in the individual name field. After you type a name, you may notice that ArcPro considers this requirement complete, and the organization and position fields may disappear. That's expected, and you don't need to add anything else for this lab. Role. The role field explains how the metadata contact is related to the data set. It's a simple way of stating what your responsibility is, such as whether you created the data, published it, or are responsible for maintaining it. For this lab, you're the person who created and documented the dataset, so the appropriate role is author. Suggested metadata elements. At this point, you'll notice that ArcGIS Pro also lists some suggested metadata elements. These aren't required to meet the basic ISO requirements, but they can still add a useful context. In real GIS work, suggested fields are often filled out when a dataset might be shared, reused, published, or archived because they help other people understand and find the data more easily. For this lab, you don't need to complete every suggested element, but we're going to work through a couple of the most useful ones. Tags. Tags are keywords that describe what your dataset contains. You can think of them like hashtags. Tags are also one of the main fields used for searching. When someone searches in the catalog pane or in a portal like ArcGIS Online, ArcGIS looks closely at the title, summary, and tag fields. So clear, relevant tags make your dataset much easier to discover. Enter several keywords that describe the dataset and separate each one with a comma. Even though it looks like one text box, the commas help ArcGIS treat each keyword as its own tag. Summary. The summary explains why the dataset exists. It's a short, plain language statement that describes the reason the dataset was created and how it's intended to be used. A good summary focuses on intent rather than process. It answers questions like, what is this dataset for, and who is it meant to support? The summary is also one of the fields that helps people find data. It often shows up as the short preview text under the dataset in search results, kind of like a snippet. So it should be clear and meaningful, even if someone never opens the full metadata. Enter 1 or 2 sentences explaining why the dataset was created. I'm going to use the example from the instructions. Don't forget that this example applies to the buildings. You'll need to write new ones for the streets and trees. Skill drill, completing your metadata documentation. Now that you've completed the metadata for the buildings layer, this is your chance to practice the same workflow on your own. Go back to the catalog pane and create metadata for the trees and streets layer. Use the same process and let the required elements panel guide you as you work. Once you've finished metadata for all three layers, you'll be ready to move on. Finalizing and submitting your work. Now that you're finished digitizing and adding metadata to all three layers, you're ready to package your work for submission. First, save your ArcGIS Pro project one last time, and then close ArcGIS Pro completely. This step matters because ArcGIS Pro can keep files locked when it's open, and that can cause problems when you try compressing your folder. Next, open your working folder in the Windows File Explorer and do two quick checks before you create the 7Z file. First, make sure your shapefiles include all of their component files. A shapefile is not just a single .shp file. It's usually a small group of files stored together, so you should see several files for each layer. Second, make sure the large NAIP imagery is not in your working folder. The NAIP files should stay in your original folder only. If the NAIP imagery ends up in the working folder, your submission file will be huge, and it's a good sign that something went wrong, so you may lose points. Once those checks look good, right-click the working folder, find the 7-zip menu, and choose Add to Working.7z. This will create a compressed file in the same location. Finally, rename the file by adding your last name to the beginning. You're now ready to submit. Check the assignment page in Canvas for the exact submission instructions.